So welcome back to my channel. I'm Tepin and this is the second lesson of maximum parsimony, and here we're going to learn how to do parsimony analysis for partitioned dataset. So we can close this one. Again, you have to do uh, uh, alignment and then trimming and then combining the dataset, but I've already done that. Here you can see I have combined both ITS and LSU here for this characters, and you have to make a file like this: begin sets character set, I mean ch car set its is equal to 1 to 1 1 to 446. This is defining that your data has its with length this one, and we have lsu with length this one. You can save and then close. And now we are going to, of course, transform this from faster to Nexus and then produce this file. This is the Nexus file, and at the end we have to paste this begin characters, all these things, begin sets, yes, these things you have to paste it after the sequence, this end. Okay, and then you can open Paup and open the partition dataset. You can see this is the partition dataset, and now we will activate the partition one as its dash lsu, right? And that is its is from 144, sorry, 1 to 146, so sorry, 446. Then lsu is equal to, sorry, is equal to this is your partition. Okay, now what we're going to do is, first, before maximum parsimony, we're going to do partition homogeneity test, because this will tell us uh, if we are supposed to, add, combine the partition or not. But that's not very compulsory. You can, so press OK, and then we have to, you don't have to set max 3 here. You can just set 1 because it won't matter anyway. Leave unchanged, and then stepwise addition, you can choose 1000 here, won't matter anyway. Press OK. So you can see our partition is has p-value less than 0.05. We are not supposed to combine both datasets, but we can also analyze it. It's not compulsory. So now we are going to do heuristic search again. Same thing. Here we have to set max 3 to 5000 again. Okay. Same thing that we have done previously. Nothing fancy. So it is done. Here we have 166 parsimony informative characters, and we have only one tree, and this is the number of rearrangement tried. Now you can see the tree here, same thing with that we have done previously, and you can see, okay, here we have collapsed branch. So if you don't want to see, prevent collapsing, okay, and now we can do analysis. and then you can see the tree. If we didn't collapse the branch, then we can see that there are three trees that can be generated, and from these three trees we can filter the best trees, or we can also see the three trees, so trees, all trees. So this is the best tree. The first one is the best tree. Let's filter out and see what it chooses as the best tree. Best score 1. Okay, now you can see, yes, this should be together. Now we can set our outgroup as this one. I know it is already selected, but we will select this one as outgroup anyway again. So Paup by default chooses the first taxon as outgroup. Okay, chooses the first taxon in your dataset as outgroup. You must remember, you should remember that. And then you can do bootstrap objective 1000, resample, continue, to change this to 10, starting 3, maximum 3. Okay, you can see this is the tree. Okay, it has collapsed the tree again. We have to prevent it from collapsing. Where is it? Okay, it's not collapsed now. You have to set the collapse first. You can see the bootstrap values support of for the support of the nodes. You can also choose outgroup GRUP as 1, 2, 3. So the text up within one, not like this. 1. Okay, outgroup. Yes. Now we can do the analysis again. This time, let's try this. Okay. Then bootstrap. It is collapsing. So to prevent from collapsing, we can do what we can do is we can do this. Also add sequence replication a little bit more, like 40, to have more stronger support. Okay, no problem. Since this dataset is small, so it is not producing what I'm expecting it to produce. But anyway, we can now save the tree, same as we have done it except as we have done before. File mp bootstrap.tw from 1 to save would be node levels partition mpps. This is the bootstrap tree mpps tree bs. This is the node values, and to save the uh, tree with branch length you have to do the same thing again. 1000 here, page search, maximum tree 5000. Okay, it's okay, and then you have to save. Now save tree. You have to save, you have to analyze each and every time. For example, if you want to have branch length tree, then you have to do edge search and then save the tree. If you do it after the bootstrap analysis, you won't be able to save the edge search tree. Here, so this is how you do maximum parsimony. In case of maximum parsimony, if your homogeneity test is less than 0.05, p value is less than 0.05, then usually you are not supposed to add both the combine both the dataset. You can analyze them separately, but you can also combine them and analyze the dataset, or you can do other analysis like maximum likelihood or Bayesian analysis, where they analyze the partitions and their substitution rate independently instead of analyzing them together. But in Paup, in maximum parsimony, they don't estimate anything like that. They just consider all the characters as same. They all have equal weight. That is what maximum parsimony is. Parsimony will simply just take whatever it has and put them to have equal weights and do the analysis. So that's it for maximum parsimony. I hope you learned something from these lessons. Maximum parsimony is not that hard. So I hope you learned it, and thanks for watching, and don't forget to hit like, share and subscribe. And if you have any more query, please comment below. Thank you. See you next time.